You're listening to The Solution, a podcast by Growers Mineral. I'm your host, Russell Bobel. This is the second part of our discussion with Marguerite, Jim Halbeisen, and Zach Smith, where they get into soil microbes. We do a monthly series on this channel, The Solution, where we listen to sections from More Food from Soil Science, a book written by Dr. Tegens, one of the founders of Growers. The June episode is out and covers the introduction and preface. In July, we'll be releasing the episode on Chapter 1 titled, Abundant Crop Production and Good Nutrition Must Be Well Integrated. Make sure to go give those episodes a listen. The series is titled MFSS. Now, over to Marguerite, Jim, and Zach for their discussion on soil microbes.
So, Jim, Zach, thanks for joining me again. We're going to talk a little bit about soil microbes today. So, just to start off, Zach, could you give me just a quick little background on what soil microbes are? You know, I'm not too familiar with them.
Sure. They are, in the context that we're talking about, they are microscopic, meaning they cannot be seen with the naked eye, organisms that live in and on soil particles. So we're talking there's bacteria, there's fungi, there's something called actinomycetes. There are others as well. They, like we're going to focus on later in this, they exist like any other ecosystem. They have relationships with each other, whether that be predatory, parasitic, symbiotic. They are vital to soil health. They are vital to every single ecosystem that they exist in. Our forests wouldn't look like they do without them. Our fields wouldn't look like they do without them. Grasslands, anything, swamps. They perform services that we might not be able to see in short periods. We can certainly see them over time, like the breaking down of dead matter. But without them, nothing would live in these ecosystems. So they are very important.
So I know one of the methods that farmers discuss is the bug in a jug method, where, you know, if you believe that your soil is depleted in one of these soil microbes, you may add just one specific microbe in, right? So can you tell me when did they start recommending bug in a jug method? How did this come about?
In the late 60s, early 70s, up to World War II, farming was rotational type of farming, where you grew your feed for your animals and then you grew other crops that would be saleable more easily, like corn or soybeans, but your forages were fed to your livestock, and then your livestock waste went back out onto your land, and the amount of fertilizer that you needed to add was minimal. As farmers went to less livestock, as livestock industry became more concentrated, the fields started to show issues that the lack of rotation was hindering production. And fertilizer was not, they just said, well, put on more fertilizer and that'll solve the problem. Well, it wasn't doing it. And then these companies got the idea that the lack of microbial activity was really holding back production. So they started to come out with materials, liquid materials that had various species of microbes in, and you sprayed it on, and that would improve the biological in the soil so that your yield would come back and you could back off on the fertilizer again. And that started in a particular area, Texas. There was a gentleman that really was the champion of that particular thing. He was a microbiologist, and it went to various areas of the country, and there was a lot of, hucksters in it. Guys would have success, use the same product again, and the success was minimal. So it was going through a lot of growing pains, and it's just built from that point. And some areas, they resist it, some areas embrace it. And more recently, we're seeing with the nitrogen loss into water systems that there are actually biological companies where they're introducing microbes that will fix nitrogen out of the air onto grass crops where you use a lot of nitrogen.
So did you ever use this in your personal farming, Jim?
Yeah, we had a product we used in 1975 that was called Trasco. It was basically they didn't they didn't warn it as a nitrogen replacement. They warned it as a fertilizer replacement. So we used it in conjunction with the growers, and our success was through test plots were just not very encouraging. Then in the early 80s, there was a product called AgriSpawn that came along that was advocated as a nitrogen replacement, as some of these ones we're seeing today. And we used that for a couple of years and had very good results with it. And then as we went farther along, the results started to be more shaky. And we just felt that their business tactics were giving them problems, and we weren't getting what they gave us originally. And since that point, we've used other products very sparingly because we just were very concerned that there's a lot of hucksters still left in that particular business. So it's ebbed and flowed with agriculture over a period of time to where recently now you have a lot more interest in it because the introduction of cover crops have convinced farmers that this biological factor is a big issue in their soil.
So kind of going off that there might be people trying to rip you off somewhat.
Oh, yeah.
How do you know if the product's a good product? I know Zach had mentioned sometimes farmers would test it and discover that the bugs in there were not living anyway.
Right.
And that's very concerning. So how would they possibly know that they were getting something of good quality?
Excellent question. Just go to the field. You put in test plots where you use the product, you don't use the product, and then you let Mother Nature talk to you at the end of the year with your harvest. And that's really when we first implemented the AgriSpawn material, we got very nice yield response to that, and we're able to back off on our nitrogen levels. But then eventually we were seeing in our test plots that wasn't working anymore. So that pretty well tells you if you're getting ripped off or whether you're getting good product. There's a certain amount of explanation or theory to it, but it's got to work. So.
Yeah, absolutely. So I know there's been some controversy around this method. Zach, can you tell us a little bit more about what some of the criticisms of this method are, maybe?
Yeah, sure. I'm going to lay a foundation first so that people understand why I don't believe that applying microbes as if they were a fertilizer, so to speak, is a broadly successful venture. So, like I said in the introduction to microbes, we need to view them as an ecosystem. We need to view them as functioning with each other. The 2 points that I brought up in my article, the first one being that soil microbe populations should be stable, which means that they exist without immediate threat to their population, but they should not be static. So they shouldn't always be the same. The second point is that the relationships between soil microbes interact the same way as any other food web. So there needs to be a diversity in population to have a functioning system. To bring it down to a more understandable level, think of a forest ecosystem where you have a rabbit, you have a deer, you have a fox, and you have wolves. Those species all interact to keep that system functioning normally. Vegetation grows, the rabbit and the deer eat the vegetation in order to keep it under control. The foxes eat the rabbits to keep the rabbit population under control, and the wolves eat the deer to keep the deer population under control. If I go in there and suddenly decide that I want to introduce an entirely new species to that mix, let's say an elephant, because I like elephants and forests that elephants live in look nice, and I think this will be helpful. I'm going to upset that entire system. They will trample the vegetation. They might outcompete the deer in the vegetation, thereby leading to the downfall of the deer population. Wolves can't hunt elephants, so if you lose the deer, you lose the wolves. And I don't know what would happen with rabbits and foxes. There's unknown there as well. The same principle applies when we're applying man-made, they're not man-made, but the man-provided microbes into the soil. There are existing populations there. We don't know when you apply those other microbes in there, we don't know what they're going to do to that system. The most likely thing and the most common thing is that they are not adapted to it. They're going to be outcompeted by the existing microbes, and they will die, and you'll have wasted a bunch of money.
But there is
Less
the
likely, but still
potential
common.
they could be invasive.
Yes, so that'd be the next point. They could survive, and they could upset the balance of the system that's there. Same as an elephant would if you introduced it into a forest around here. And like, I want to be clear that we're never going to destroy these ecosystems. Man can't destroy ecosystems. He can just change them beyond anything we recognize and anything that might be useful to us in agriculture. So that microbe that you just introduced could proliferate, could outcompete other microbes, and suddenly you're losing other benefits that you had from them, all in favor of this one population that you decided you needed. That's the outcompeting factor. The reason I brought up those 2 points, that they should be stable and that you need diversity, the stability and the resilience of an ecosystem is huge. Stability meaning that it's not constantly changing drastically, and resilience meaning that it has the ability to bounce back from minor changes. If we're just introducing new microbes every year because we're trying to get better crops, we are drastically changing that ecosystem. That's not stable. And eventually we're going to lose resilience if we change it enough, where it's going to change drastically and stay changed. And the relationships, the diversity and population story that we need, again, if you keep introducing a single microbe population into the ecosystem, eventually it's going to overwhelm it. You're not going to have that diversity anymore because you're not encouraging it. And that's really what it comes down to, is that the main criticism of what I'm saying is going to be that an agricultural field is not a forest. It's heavily managed. We need to do something with the microbes in order to help us out. Otherwise, we'll probably lose yield, lose quality, and potentially lose fertility in the field. And my response to that would be, the answer is not to add microbes in that we think we need. The answer is to create the conditions in the soil that optimize the microbes that are already there. So that's removing negative actions that we do, like applying toxic fertilizer, applying too much herbicide or fungicide. And then we can also promote healthy populations by aerating the soil, providing the things they need for life. What do they need? They need oxygen. They need carbon, which can come in the form of organic matter or the exudate from roots. I should say, or the exudate from roots. And they need a functioning ecosystem, a functioning food web as well. But that's the basics of why I don't think fundamentally these bug-in-a-jugs are going to be broadly successful, because they can't account for all of those problems, and they also can't account for the diversity in soil, the diversity in crop, the diversity in climate, even from field to field, diversity in the populations that are already there. You could have 2 fields that have very similar rainfall amounts, very similar soil types. They're obviously in the same climate, and one field could see benefit from a bug in the jug, and the other field could see nothing. And that can entirely be because the populations in the soil that are already there are different, and they've reacted in different ways.
So what would you say?
An efficient way of seeing success.
So what would you say about farmers who are having some success with the bug in a jug method? Would you think that if having success, it would only be short term?
I think that's certainly a possibility. Like I said, they can't account for the variability, and by nature, variability, you're going to have some success and some failure. The failure is going to widely outpace the success, but you will see some of it. I don't know if they're going to see success in the long run. Jim didn't in the 80s. We can't say definitively why that is. It could have been that they gave him a bad product, or it could have been that the populations in his soil had become unbalanced and no longer supported what he was applying. Again, field trials are going to tell you that, a better idea at least. So I understand some guys do see success, but I don't think it's trustworthy enough to kind of bet the bottom dollar on it.
Absolutely. And so that is one major criticism, of this bug in a jug method. But another criticism I mentioned was you said that sometimes farmers have taken that product and tested it and found that the bugs in there are in fact dead.
Mm-hmm.
Are there any other criticisms too?
That about boils it down for me.
Okay.
But I mean, those are two very major criticisms.
Absolutely. And so if not the bug in a jug method, what is a good method to do to provide them with next? What should farmers try next?
Well, I'm going to be putting a plug in now, but the growers program, to be completely serious. Like I said before, we want to optimize the growing conditions for them, the ecosystem for them. And like I said, they need oxygen and they need organic matter, carbon. And limestone is an excellent way. High calcium limestone is an excellent way of aerating the soil and creating a healthy crop that will release root exudate. Now the carbon, the organic matter portion, agriculture naturally has less organic matter than, say, a forest ecosystem just by nature of what it is. However, if guys are leaving some crop on the field, say, I mean, rotation, like Jim brought up before, covers that very nicely. You get a hay crop that you're cutting, you get corn stover left over, you get stuff like that. That's plenty of organic matter. If you're getting a very simple rotation, I can see that being more of an issue. And that's why no-till has come around. However, no-till can't account for getting oxygen into the soil very well. And if you can't have organic matter without oxygen, just like if you have oxygen without organic matter, you're still not going to have healthy populations. So that's a little bit of the organic matter is a different animal to tackle. It can be tackled though, but the growers program accounts for oxygen in the soil and not putting on toxic fertilizers. We talked earlier today about beneficial and non-beneficial, or the better term perhaps being directly beneficial or indirectly beneficial. By applying toxic fertilizers, we are changing the balance of the populations in the soil to better reflect detoxifying rather than direct benefit to the crop, being nutrient, protection from pathogens, even decomposition, basic decomposition of what's there. And we've seen that in lots of soils. Soils that are black, that have lots of organic matter, but that they don't break it down because they've had toxic substances applied to them for so long that the populations in there are simply breaking those down rather than breaking down the organic matter or having a symbiotic relationship with the plants.
So just to clarify and maybe simplify what you're saying a little bit, I think what I'm hearing is that really the soil is what we should be relying on. We shouldn't be trying to significantly alter our soil. We should be trying to support it, and maybe not that it necessarily needs as much help as we always think it do. We should have a little more trust in our natural soil that crops are going to get what they need from the soil. Is that?
Yeah, you're absolutely right. That's a great way of putting it.
Yeah, the environment. You're trying to create an environment in the soil that allows the microbes that help grow your crop the best to exist. And so you create certain microclimates in there with the approach that you use. And that's what Zach is referring to. You need air. Calcium helps with that. Then you have to feed them properly, because the soil those microbes will create an ideal environment. And the easier you make it for them to do that, the more efficient they will be. And see, the idea is you're relying on the populations that are already there in the soil. They have been selected for some reason. Now, is that better than some man-made conception of what we need? We say yes. So we're trying to change that environment and work with what's already there rather than artificially adding to that environment.
Yeah, so I think really, to sum up this conversation, what we're discussing is that the solution is not to add in something to do the bug in a jug method. Really, the solution is to trust the soil that you have and give it the best support that you can.
Yep.
And use that soil and rely on that as opposed to trying to change or alter the ecosystem of the soil.
Right.
Exactly.
Yep.
Absolutely. I really appreciate that. I think that's a really good conclusion to this bug in a jug method. So thank you for breaking that down and explaining it to us today. And we'll talk to you guys another time.
Thank you.